positive value of x at which the curve has a vertical tangent line. Show the work that leads to your answer.
Okay, so positive value of x. So if they're saying positive value of x, is there a chance that at the end I might get a positive and a negative answer?
Yes.
Yep. And then we're looking at a vertical tangent. And I want to box the word vertical. When we had a vertical line, it was undefined, right? And it is undefined when it is 0 on the top or the bottom of the fraction. Bottom. So I'm going to go ahead and circle the bottom and say this guy right here must equal 0. So we have 3y minus 2x must equal 0. Now for cases like this, you can solve for x, solve for y. It really doesn't matter. But I want to avoid negative numbers. So I want to solve for y. So I'm going to move 2x over, positive 2x, and divide it by 3. And it wants it on the curve. And the curve is the original equation given on part A. So I'm going to go ahead and use substitution and plug it in. Meaning, anywhere I see a y, we're plugging in the value of 2x over 3. So we have 2x squared plus 3. And in parentheses, 2x over 3 all squared minus 4x, again in parentheses, 2x over 3 is equal to 36. So we have a common variable, meaning we can solve for this. Okay, let's do some tedious math. So this part right here, I'm going to write every single part, because why not? If I square the 2x, we get how many? 4x squared. If I square the 3, what do we get? 9. And I think we can also simplify this one a little bit further. Negative 4x times 2x is negative 8x squared over 3 is equal to 36. And what's nice about this problem is that we have x squared throughout the whole thing. So we can at some point use common denominator. But I want to simplify this right here. 3 over 9 simplifies to what? So 4 over 3? And I'm not writing the next part on purpose. I mean the beginning part on purpose. Over 3 x squared. So then, since I have a common denominator of 3, let's go ahead and rewrite this guy right here into something over 3. Something over 3 is 2. What is that? 6 over 3. And that was plus. So we have a common variable, so I can add all the fractions. So 6 plus 4 is how many? 10 minus 8 is how many? So we have 2 over 3 x squared is equal to 36. And I think I want to multiply by the reciprocal. So we have 3 over 2 and 3 over 2. All that goes away. So that means my x squared is going to be some whole number. So let's do the mental math. What is half of 36? 18. 3 times the 18. 54. Now we do want to square root this. When I square root this, we get a clean number with a perfect factor of 9. 9 and what? 9 and 6. Y'all remember back in Algebra 2 when you square rooted on both sides, you didn't just get a positive answer, but also what? You had a plus or a minus answer. So we have 3 radical 6. So then again, AP test likes sentences. So we're going to write out x is positive. So that means my x must be what number? Positive 3 radical 6. And the way they're going to break down the points is noticing that the denominator has to equal to 0 is 1 point. And also noticing the positive number must be our final answer is another point. Do we apply calculus at all here? Okay. Let's go on to the bottom then. Okay, Will, let's read the bottom, part D.
Let x and y be functions of time, t, that are related to the equation 2x squared plus 3x squared minus 4xy equals 36. At time t equals 1, the value of x is 2. The value of y is negative 2, and the value of dy over dt is 4. Find the value of dx over dt at the time t.
Okay, So far when we were deriving this one, we derived with respect to x, right? This one is saying basically derived just like the related rates. Meaning, as long as it's not a t that we're deriving, we still have to put dx over dt, dy over dt. So let's practice that. Rewrite the original. We have 2x squared plus 3y squared. And I'm going to write this in, or I'll rewrite it after this, never mind. Okay, because I see a product rule, let's write negative 4x times 1y. I think my hand's giving up on me right now. Okay, so what is the derivative of 2x squared? And then this is with respect to t, so I need 4x dx over dt. What is the derivative of 3y squared? 6y, and then we need dy over dt. And then we have our product rule. We derive the first one, which is minus 4, and that's still dx over dt. And we keep the second piece, which is y. And then I keep the first piece, which is minus 4x. And when I derive the next piece, it is 1, but we also need dy over dt. And I'm going to give you a shortcut after this one that you might care or not care to write. So try to leave a little bit of room over here. I don't think I did a great job. Let's factor out the dx's first, right here. So I'm going to write out dx over dt and put the remaining inside the parentheses. 4x minus 4y. And then let's factor out dy over dt. So we have plus dy over dt. And write the remaining inside the parentheses. I have 6y minus 4x is equal to 0. So from here, it's just substitution. They gave us x. We know the y. We know dy over dt. So since we're looking for dx over dt, that's going to remain. And then let's plug in the x and y's. We have 4 times 2 minus 4 times negative 2. And then we know dy over dt, so let's write in 4. 6 times a negative 2 minus 4 times a 2. And I want us to compute this guy right here and all of that. Should give you clean whole numbers. Isn't that 8 plus 8 basically? So is it 16? So I'm going to write dx over dt times 16. Before I multiply by 4, are we getting 20 or negative 20? Okay, so negative 20 times a 4 is going to give us negative 80. And then we're solving for the dx over dt. So that's going to give us, add 80 on both sides. Oh, not 180. Can 80 be divided by 16? Is it a clean number?
Yes.
What is a clean number?
5.
5, very good. 80. Oh. So we know dx over dt is equal to 5. And our breakdown is going to be the following. Deriving implicitly, 1 point. Factoring out dx's and dy's is going to be 1 point right there. And our final answer is going to be 1 point. So now I'm going to give you a little shortcut. If you care for this, cool. If you don't have to write it. So if you just want to watch, I'm okay with it. Okay? All right. So far we had dx over dy, dy over dt, and dx over dt. There's something unique about this one. I could say dy over dt in this manner. Dy over dx times dx over dt. Let's see if that is true. On the right side, what is identical on the top and the bottom that I could cross out? So if I cross out dx's, do I really get to dy over dt? Okay, so then let's plug in what I know. We know dy over dt is given to us 4. And we know dy over dx was given on part A as 2y minus 2x over 3y minus 2x. And we're looking for dx over dt. So here's what I want you to do. I want you to plug in the -2 into the y's, 2 into the x's. Simplify it and see if we get the exact same thing. Go. If you simplify the fraction alone correctly, you should have gotten 4 over what? Yeah, 4 over 5. And if you multiply by the reciprocal, that's going to give us 5 also. Boom.